Welcome to the lecture series of algebraic geometry. So today it is a very introductory session. I will just briefly discuss what is our goal and who are the target students for this lecture series, and also the books and references that we are going to cover. Of course, so let's start with goal first. So this lecture series has aimed to discuss with scheme. Of course, we'll start with sheaf, pre-sheaf, scheme, sheaf of modules, properties of scheme as well, here we will discuss something called Noetherian scheme, also fiber product, and separatedness. Then we will cover separated condition, and of course separate morphism, divisors, and finally brief discussion with formal scheme and its application. So this is our primary goal and all these topics that we will be covering throughout this entire session. After that, if we get some time, then we will just give you an overview of, from the aspect of formal scheme, of deformation theory. Right. So our aim are mostly the students who are interested in study core algebraic geometry. So of course not the first year or second year students, only maybe they have taken third year, they're in third year or fourth year, they are only our target audiences. I mean, if anyone is interested to study geometry, they are most welcome to this session. Now, most importantly, let us shortly discuss what are the prerequisites. I'll be assuming something that you all are familiar with basic algebraic notions, including, let's say, group, of course, rings, and modules, as well as field and field extension, also you should be familiar with basic commutative algebra, at least tensor product, of modules, Noetherian and Artinian ring and modules. Maybe some point of view we should need the integral extension, but in that case I will give a short amount of time I will spend with this topic, but you have to be very much prepared with rest of the others. So these are all the prerequisites, and not, sorry, not as a whole, but property of curves and surfaces. Maybe some basic notion related to manifold, because we'll be defining something called Zariski tangent space. So there we need the basic property of tangent space to be induced from the definition of manifold. Right. So all these three are prerequisites. Now let us come to the books. So I will just make a partition here. So for algebraic geometry, we'll mostly follow the book named Algebraic Geometry by Robin Hartshorne. It is basically a GTM series, Graduate Text Mathematics. It is available in online. Of course, I mean, and also it is a very, very standard book in this way. And for references, we may look at Algebraic Geometry 1 scheme by Ulrich Gortz and Tota. And also you can have a look at Red book on algebraic geometry by David Mumford. Okay. So these are for studying algebraic geometry, but of course we will study, of course we'll cover the second chapter. If you see this book, whatever we have enlisted our goal of this lecture series, we'll mostly cover the chapter 2. And context plus exercises. Okay. Maybe not all the exercises will be it will be possible for us to discuss all the exercises, but of course a significant amount of exercises will be covering here, and sometime I will be giving some hints and give an exercise for you guys to have a headstone by your own. Now, if whatever I have written here, that as the prerequisites, if any one of you is not familiar with any of these prerequisites except this integral extension, except this one, if you are not familiar with any one of this, for that purpose let me write as well for basic algebra, not the commutative algebra. For basic algebra, you can follow something called Thomas W. Judson. It is not a very standard book, but it is easy to read. As well as you can follow Ian Herstein, but of course Damit is a best one. For commutative algebra, I will suggest you to go the introduction to commutative algebra by Atia MacDonald. Of course, exercise must. And for building concept, basic commutative algebra, you can follow by I think by Balwant Singh. Yeah. Here you can of course visit the context and if possible exercises. Of course, if you go through both the books, you will find that both are actually complementary to each other because this commutative algebra and basic commutative algebra by Balwant Singh and Atia MacDonald are basically complementary to each other. Whatever are there in the exercises of this Atia MacDonald, they are included as a textual assignments in basic commutative algebra by Balwant Singh. So I will suggest you that deal with both the books. And at the end, for basic differential geometry, to have this property of curves and surfaces, and of course a manifold, you can follow Christopher Tapp. Also, Docarmo is a very good book, and Lie manifold. Okay. Sorry, not by manifold, by John Lie. So I'm sorry for the mistake. So it is manifold by John M. Lie. The book usually is a Lie manifold, but the name is manifold by John M. Lie. So all these are the books that you can follow for prerequisites. Okay, and if you, I will suggest you that have some time to brush up with all these prerequisites from these books, make yourself comfortable, and then go with the lecture series. Then it will be easy for you to understand and follow whatever we will be discussing here, because otherwise every time you will need to read the context from algebraic geometry, then again for every second you have to move to this prerequisite. So for this, rather brush up all this context and prepare your base more strongly, then you start this algebraic geometry. Okay, so we'll be I've just written all these contextual things that are going to be covered. So prepare yourself. With the next lecture onwards, we'll be starting with pre-sheaf, oh, of course, I need for pre-sheaf and sheaf. I forgot to write one thing, that here most importantly, category theory. Okay, so for category theory, I will suggest that you should go to Balwant Singh. Then it will be easy for you to understand whatever they are to follow the context, because category theory mainly the functors, covariant or contravariant functors, these are going to be helpful at every step of algebraic geometry. So we'll be starting with pre-sheaf and sheaf. I believe that you are free to deal with topology. If not, I haven't included here, because if not, then also let me add here by Moncrish is enough, or maybe Simmons. For topology only, okay. So pre-sheaf and sheaf these are nothing but basically a way of, or a channel of transportation from a topological space to the from the open sets of topological space to the category of abelian groups. Means it is for every open set of topological space, I can assign a abelian group here. So that is this channel of transportation, that is taking up open set to an abelian group. This introduction is basically known as pre-sheaf, and there are some other properties which is known as sheaf. Based on pre-sheaf and sheaf, then we will go on with the next topics. Okay, so let's call it a day. I hope you will follow these instructions, whatever we have given here, and from next day onwards we'll be rigorously studying geometry. Okay, thank you very much.